What?
The absolute value is into the calculator how?
Yes. Yeah, you have to hit the math button right to the numbers tab. First one, abs. Yep. It's 8:35. Okay. We're going to do, I think, 2 more cycles. Next cycle is over reflections. So if we want to reflect something, you just apply a negative to the function. Be careful which one you apply it to. If you think, that y is your f of x values, if I put the negative in front of my function, then I am changing like its y values from, if they were positive, they would become negative, and if they were negative, they become positive. So that reflects it over the x-axis. Goes from top to bottom or bottom to top. Okay? If the negative is inside the function, then that would reflect it over the y-axis, because then I'm changing the sign on my x values. So my positive x values become negative, negative become positive. Flips it over the y-axis, left to right. So again, what that could look like, or the difference between those, is if we were doing a square root function, this would flip it over the y-axis or x-axis, and this would flip it over the y-axis. You don't have to draw. I'm going to do more examples, so you don't have to draw these. But right, that's the square root of x. This is the negative square root of x, and this is the square root of negative x. And this would be the negative square root of negative x. Flip-flop. What was it? Was it Lily and somebody else? Somebody went to Nothing Bundt Cake. Did you end up going? Was it good? Oh, see? Yeah, it was good. I'm glad. I should go there after work today. I see that. Then it hits 3:30 and then I'm just exhausted. I can't imagine, I don't know. I feel like it's much more exhausting to do remote learning than it was in person. I don't know if that's true for you all, but it is for me, because for me, I could get a lot of my energy, from the crowd, right? Here it's just like, whew. All right. All right, I'm going to clear and move on unless somebody says no. Nope. White chocolate raspberry? Ooh, I'm not a big fan of raspberry. I do like white chocolate though. Okay, this is what I'll do. I'll go there and I'll get 4. That way I get the bag and I'll get that as one of the 4. That way I can try it, but if I don't like it, I have a backup. White chocolate raspberry. They've got a punch card thing too, but I don't have the punch card. My wife has the punch card. I guess I could get a punch card too, and then we both have punch cards. No, no, not. I could stop eating cake anytime I wanted to. I'm not addicted to the cake. Oh, they have a pumpkin spice one now? I do like me some pumpkin spice in food. In drinks, it's weird, I feel like. Like I can't get pumpkin spice coffee. I feel like I want to like it more than I do because I'm a big fan of fall. I love the fall. All right. So this we're going to now do the opposite. Last time we graphed it from equations. Now we've got the graph. We want to write the equation. So the first thing you should notice when you're trying to do these problems on the homework is what's the parent function? These are parabolas, or quadratics. So the first thing you should know is that the parent function why do I write out the whole word? I didn't need to write out the whole word. Is x squared. I could stop eating cake anytime I wanted to. I just don't want to right now. All right, and then you should list, so that's the first thing you do. The second thing, you should list what the transformations are. So it looks like, remember, if we think a normal parabola looks like this, right, where it goes through 0, 0, that's a normal parabola. This one has been reflected over the x-axis, so instead of facing up, it now faces down. It has also been moved up 2. So instead of being at 0, 0, it starts at 0, 2. So this one has gone reflect over x and up 2. And then if you already have those memorized on what those do to your function, you can just go for it. Or you go back in your notes and you say, okay, if I want to reflect something over the x-axis, what do I do? Okay, I got to put a negative in front of the x squared, not inside the parentheses. If I want it to go up 2, what do I do? Okay, I put plus 2 again after the function. So what this would look like is g of x is negative x squared plus 2. All right, we do the same thing for this one, okay? Again, parent function is x squared again. This one has also been reflected over the x-axis, right? It's facing, instead of facing up, it's now facing down. And it has moved to the right 3. Right, instead of starting at 0, 0 like it should, it starts at 3, 0. So this one has gone to the right 3. And again, then you might consult your notes and say, well, how do I write the function then so that it does those things? And again, the idea here is h of x will be, I put the negative in front, and then I need to put the plus or the minus 3 inside the function. So wherever I see an x, I instead write x minus 3 squared. What do you think? Not too bad? Or is this terrible? Okay, most people are yawning, so I'm going to guess that this is not too bad. By most people, I mean 2 people. These two. These 2 yahoos right here yawning. Okay, good. All right. I'm going to clear and move on unless someone says, no, wait, hold on. I was getting a pumpkin spice coffee. I didn't have to. Okay. All right, your turn. Write the equation for this graph. Okay, let's see. Nope, that's not the right tab. Okay. That's good. Okay, that's not. That's not. That's good. Good. That's not. That's not. Oh, that's not. Oh no. Oh no. Oh no. This is bad. This is, oh, this is bad. This not good. Okay, hold on a second. Hold on a second here. Let's do this. Come on. Okay, so it looks like everyone did notice the parent function is x squared. Okay, and it looks like everyone noticed that this is a reflection. That's first step. Second step, reflect over the x-axis and then left 2. The question then becomes is, it looks like the third part is where we messed up. How do we write that equation? Breakout room? Let's do it. We haven't done a breakout room, Ron. It'll give you a chance to meet each other and talk to each other, and that kind of stuff too. It doesn't, I mean, it doesn't have to be bad. So let's say, okay, so we've been talking about food. So I want you to share your favorite food. Okay? And everybody give your answers, and then when there's disagreement, argue about it until you're going to bond over the favorite food. That's the start. You're going to be in the breakout room. There'll be 3 people there. Okay? You're going to all share your favorite food. Okay? And you're going to bond over that. But then you're all going to share your answers and disagree, and then you need to fight until one answer remains. Okay? So bond over the favorite food, and then you can have a friendly disagreement about the math. Assign. Oh, what? Oh, no. Okay. Okay, there it is. This is weird. They have changed how this looks. I don't like that. I don't like change. Okay, one group gets 4 people. All right, you should have room to join. Hey, you 3. Okay. Emma, join a room. Dylan, join a room. Okay, take it.
Are we the only ones in here? What?
Literally, yes. He probably went to another breakout room.
Oh, there's some people.
Quit playing, man. It shouldn't take this long.
Okay, hopefully you all got that since this is the parent function is x squared and it's reflected over the x, then if you look at your notes, and if I want to reflect something over the x, I do negative f of x. If I want to move something left 2, then I do f of x plus 2. So then the answer you should get is if I apply both of these things to the x squared, the negative will be out in front. And then instead of x, I'm going to write x plus 2 squared. And that's your answer. Whoop. Yay? Did any group come out of there and was like, whoa, nuh-uh. Does that make sense to everybody? All right, we'll take another 5-minute break. 9:05. You could try one of the ones that are like this in WebAssign if you wanted to. What's one that's like this? Number, nope, that's not yet. Like this one, number 7. You could probably answer really quickly. And number 8. And number 10. And number 12. Okay. All right. 9:07. I gave you an extra 2 minutes and everything. Last thing we're doing today. All right. So every transformation we have done so far has been rigid. It keeps the size and shape of your parabola or your cubic or your rational equation the same. These last ones do not. These transformations are change it so that the original function is no longer congruent to your transformed function. And that is because they stretch and shrink the graph. To vertically stretch the graph, again, the number is going to go in front of the function. And if the number is greater than 1, then it will stretch it. It'll make it like 2 times or 3 times as long. If the number is between 0 and 1, so that it's a decimal or like a fraction, then it will shrink it. If your C value is inside of the square root or under the denominator or inside the x cubed or x squared, like so that there's parentheses around it, then it'll do the same thing, but the numbers reverse. Just like when we were doing left to right, the signs are the opposite that you would think. That applies here as well. If the number is a decimal between 0 to 1, then it will stretch it. If the number is greater than 1, it will shrink it. How I think about that is, and it does kind of make sense if you sit and you think about it, for every, if you think like I'm going from x from 0 to 1 to 2 to 3 and plotting those points, right, where my x is changing by 1 each time, if my C value is greater than 1, then I will plot those points much faster. They'll be in a much smaller area. When I go over 1x, if C is 3, I've actually gotten the y value that was for when x was 3. And when I go over again, I actually got it for when x is 6, right? So I'm counting my x's by 1, but since I'm multiplying it before I get my output, I'm counting the y values that go with it by 3's. So those y values, which were more spread out, get shrunk to all fit in the smaller area. The other thing that can help reinforce that is, again, it's the opposite of what you would think for horizontal, both when you go left to right and when you stretch and shrink. That is probably the hardest thing about this lesson, is the fact that the horizontal does the opposite of the verticals. That messes people up every year. That messes people up in AP calculus. It's just one of those things. So if you're not confident when you're done with your graph or with your answer, because of you're not sure whether or not it did it correctly for where your horizontal number, you can always check your answer using Desmos or using your TI-84 and actually graphing it. You could also, if you don't have your graphing calculator, you could just plot points and see if the points that you're getting from your equation match the points on the graph, or vice versa if they ask you to do the opposite. Yeah, so you can always check your answer by point plotting and by graphing. That's kind of nice about this lesson. All right, I'm going to clear and move on unless someone says no. Those are the last notes for today. So if you need more time, let me know. Or I should say last, but he's got an example, which should go into your notes too, and then guided practice. No? Everyone good?
I need a little bit more time.
Okay. I look like you were writing, Cody. So now here's the question. Do I tell my wife that I'm going to nothing but cake afterward? Because she could do the same thing and try to surprise me. And do we really want that much cake?
There's such thing as too much meat.
That's what I think. I'm not going to tell her. It'll be just a nice little surprise for her. But actually, I guess she's got to stop at the grocery store on the way home. So that means she's probably not going to go pick up cake. So I think we're in the clear anyway. So I think this will just be a nice surprise. I mean, I'm pretty sure. I think I would know if I was addicted to cake. I mean, right? When you have an addiction, you know that you have it. Right? Lincoln ate most of his breakfast. He had milk, mixed fruit, and wheat bagels. For those of you who are interested. Not all, but he ate most of it. Okay. All right, I'm going to clear and move on unless someone says no. I mean, that is right. Yeah, you're supposed denial's not just a river in Egypt. Okay, so we've got the absolute value function again, right? That's the V. We want to graph 3 of absolute value of x and 1/3, or the absolute value of 1/3 of x. All right, first one. So again, we know that I'm going to use a line tool for this actually. So we know this is the normal function, right? Okay, so here's the idea. If I want to plot this one, then I know when x is 1 normally, instead it's going to be stretched vertically by 3. So my new y value would be 1, 3. When x is 2, I would normally get a y value of 2, but since I'm multiplying it by 3, I get a y value of 6. And again, that would happen on the left side as well. So it gets stretched vertically by 3. I should label these. I have gotten 1. Okay. This week alone, I've gotten 1, 2, 3, 4, 5, 6 spam calls. They're all from different numbers. So like, I feel like robo and spam stuff is on the rise, which I guess it is, but okay. All right, let's do this one. Boom. Okay, so again, the idea here is 0, 0 doesn't change at all, right? Because anything multiplied by 1/3 doesn't matter. But the idea here is this is going to stretch it by 3. This is going to be a horizontal stretch by 3. So this point, which used to be 1, 1, will instead, if I multiply the x value by 3, will become 3, 1. And again, if you point plot to check your answer, it will make sense. If we plug in 3 for x, 3 times 1/3 is 1, and the absolute value of 1 is 1. If I plugged in 1 for x, 1 times 1/3 is 1/3. The absolute value of 1/3 is 1/3. So that'd be like right here, right? You can do this by point plotting. If I go over next to this point, which was at 2, 2, again, the x value being stretched by 3 will become 6, 2. Should be like right there. And again, since this is an even function, it's symmetric about the y-axis. So I can just duplicate that over here. And then I draw my lines. Yay. Yay. And that's g of x. Not too shabby. The key is when you're doing this WebAssign homework, I mean, normally you have your notes next to you, hopefully, when you're doing the assignment, but I would absolutely have my notes right next to my Chromebook, open to this page where you have all these rules so that you can reference it really quickly for each problem. And then once you stop referencing it, you know you got it. Or I should say, once you no longer need to reference it, then you know you got it. All right, questions? Clear and move on? Okay, all right, here it is, your turn. For this one, you don't need to graph or do anything. You just need to tell me what is the parent function and then what are the transformations that are happening to it. Okay, that's it. And Pear Deck, give me your answer to number 3. I think what I'm going to do is at the end of each minute, I will put the answer. That way you get a little check if you're stuck. For the first one, hopefully you got that it was a cubic function, x cubed is the parent, and the 1/2 vertically shrinks it. For the second one, hopefully you got that the parent function is x squared, and this one was reflected over the y, nope, sorry, x, oop, x, that's what I meant, so over the x, and also up 2. Okay. Okay, it looks like nobody got all of it, but most people got, or no, I think there's one person. Okay, nope. One. Um, yeah, I think nobody got all three. There are three transformations. Most people got two of the three, and it's not even the same two for everybody either, which is kind of funny. Okay, so the parent function is the square root of x function. That's right. All right, the negative inside the parentheses reflects it over the y. The 9 inside the parentheses, since 9 is greater than 1, it shrinks it horizontally. And the -2 at the end moves it down 2. That's all three. So the negative reflects it over the y-axis, again, because it's inside the square root. The 9 is also inside the square root, and since it's greater than 1, that's a horizontal shrink. And then the -2 moves it down 2. You will notice that the book, normally we say what it's by. The book avoids that because the grammar of it can be really confusing for people. So for example, if I wanted to say this was vertically shrunk, I would say it's by 2. Or I could say it's vertically shrunk by or of 1/2. Right? Do you see the distinction there? It's shrunk by 2. That's how much it's shrinking by. Or I could say it's half as much as it was. That goes back to all the grammar and fractions that people hated in middle school. So this, I would say it's horizontally shrunk by 1/9. Or I could say it's 9 times smaller than it was horizontally. Okay, questions, comments, concerns? That's it. 6 minutes to spare. Look at that. All right. Okay, this is, I don't know. All right, so if your friend was absent from class today, what would you tell them to do to learn the material that we just covered? That's your exit ticket. And then after that, you can use these 5 minutes to relax, get ready for your next hour, work on the homework. Homework is 10 questions, due Monday. Monday next week, we'll do 1.5. Maybe start a little bit of 1.6 and finish 1.6 on Wednesday. Thursday, we'll do 1.7. And then the week after that, which will be the first day that possibly that you all will be here, the week of October 5th. 5th is going to be our review day. And then October 7th will be the test day. Spooky. So not next Wednesday, no quiz. But the Wednesday after that, test. I am really hungry because I only ate a granola bar this morning. And I have to make it till 12:50. I have to make it till 1. I'm going to wither away with no coffee. I should have. I just got somebody Facebook messaged me in the morning and I had to answer their thing. And so now it's like, I left for work late, so I couldn't stop like I usually do somewhere. And we're at a coffee at home. So I couldn't make it on. It's just the worst. I know what you're all thinking. You're all thinking, God, this guy is such a whiner. Stop whining. You'll be okay. You'll make it. And you're right. I'll make it. Boom, 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 boom. How much is homework of the grade? Is it 7.5%? Is that something stupid? Oh, yeah. Okay. What's the question about 1.3? Number 5. All right. So typing this thing into the calculator. 7x square root x minus 3. Is that right? Nope. 3 minus x. Okay. So it looks like that. So that's that one. And then increasing, decreasing, and open intervals are constant intervals. Okay, so to do that, here's what you have to do is you need to find this maximum point, which if you remember, in order to do that, I should have just used my TI-84 to start out with this. TI-84, y equals clear 7x square root 3 minus x. Enter. All right. You're going to need to change your window so you can see the top. So I'm going to raise my maximum up to 20 for my y. That way I can see the top. So it's increasing to that point and then decreasing from there to the end. To find where it's increasing to or what that turning point is, I need to do second, trace, max. And then, follow the prompts. Go a little to the left, a little bit to the right, and here. So it's 2. So it's going to be increasing from negative infinity to 2, and then decreasing from 2 till it looks like about 3, from 2 to 3. Increasing from negative infinity to 2, and then from 2 to where the graph ends, which is at 3, and you can see that here. 3. And you can check your answering test box. So increasing from negative infinity to 2, decreasing from 2 to 3. Okay? All right, that's the end of class, everybody. You have a good rest of your day, and I'll see you Monday.